All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the winter 2022 semester at George Brown. And it's week 11, part 2 of our broadcast and time together. This week we were talking about behavior trees. So a bit of admin before we start. Something that I wanted to talk about was what we're doing this week. So Lab 7, part 1, 2, and 3, that's due week 13. Guess what? When I was talking to Alex, he was saying that you guys are crazy busy right now when it comes to stuff. Actually, I've heard some things from you as well, where you said that, you know what, there's a lot of assignments brewing all at the same time, game production 2, a bunch of other stuff. So what we decided to do is decided to move out the due date for assignment 3 to next Sunday at midnight, and that gives you guys a chance to absorb some of the stuff we're showing you this week, as well as some more time to create your assignment so it doesn't clash with the existing assignments that you have, which include Game Production 2 and other ones that are out there. Okay, so that is the update for this week, so that your assignment 3 has been updated and is now due next Sunday. Okay, that's week 12 at midnight. Okay. Great. I'm glad that you guys feel happy about that, and I think that's the first thing I wanted to update with you right now. Okay, next, we have a lot to cover today. We are going to construct tree nodes. We are going to construct action nodes and condition nodes and a bunch of stuff, and that's why Alex has kindly put together a bit of a starter project. I can't even say a bit. It's a massive starter project that he's put together. And rightly so. It's pretty good in terms of where we're going to start. So we're going to start again with our project. My hope is that you've already have you've made a copy of your starter and kind of populated it in here. I'm going to do the same thing. I'm going to grab Alex's starter. So here it is right here. And I'm going to populate it inside of my, the stuff that we're doing today, which is massive. Like I told you, there's a lot to cover and super no time to do any of it. So here's my starter. I'm going to unpack it right here. So let's just do that. And we're going to rename this thing. For me, I'm going to rename this to Lab 7.1. I should call it 7 Mark 1, right? Just like you'll see in a second why. It's pretty awesome. What he's put together. Let's run Lab 7.1 and see what we get. Again, whenever we get a brand new lab, and if we're downloading something from that's not our own stuff, a couple things to do is make sure you change to x86. That's what we're supporting with this thing. And the next thing after we, add x86 is we want to go to solution and we want to retarget our solution for our system. Please do that right away to make sure that there's no clashes with anything you're downloading from us. Number one. Next, run it and see what he's given you, because that's the next thing that you should always do. Run your lab, right? The files that he's given you to check out to see if everything is okay. Okay, so first run it. And if it runs, that's awesome. That's where you want to start. Again, tons of stuff to cover today, and I found that I ran, like you saw, right to the last minute in terms of everything that we had to do. So I'm going to go super fast. There are going to be times, guys, where I copy paste and actually even put stuff on the chat for you. There is nothing else that we can do. So here, what Alex has done, which is pretty awesome, is he's got a couple things. He's got the, I'm not sure if you guys can hear that. Let's just put up the sound, share the sound here. Let's also share the audio. So this, I know what's going to happen. What's going to happen is on YouTube, they're going to detect this as a soundtrack, and that's okay, because we're not going to actually populate this as anything that's going to, we're not going to try and monetize this craziness, but this is what he's done. He's kind of put together, recreated the fight in, Wrath of Khan, Star Trek II, 1982, right? Where we've got the Enterprise as well as the NCL, and which is awesome, right? And this is Khan's ship, this is Kirk's ship, and what's happened is he's rejigged some of the background nodes so that they are now visible. A couple changes we're going to make to this to make them extra visible. But for the most part, everything is the same. We can still move around the ship and the target and all those kind of things. You can see that the nodes are dynamic; they move everywhere. And he's also changed the background in terms of our obstacles. He's made them into these clouds that are able to fit on the background map, which he's created to make it look like a space battle, which is kind of cool. Okay, notes for you guys. Remember that you cannot use, one of our conditions is you cannot use any of the assets that we share with you during our labs. It's a no-go in terms of using them for your assignments at all. You can certainly use any of the structures, the data structures, but when it comes to assets, audio, anything like that, that has to be all you. Okay, so please make sure that you get your own assets and everything else for assignment 3. This was Alex's idea, and I think it's a great one, and it works for us, but it may not work for you. Okay. So this is awesome, but we just want to make a couple changes here really quickly. So in our playscene.cpp, notice that quickly that what's happening is our ship and our target, and they're in kind of in different layers. One thing that we remember what you can do is that when you add stuff, the background layer is in layer 0, so that's where it should be. So layer 0 is where the background layer should be. You can actually specify the layer index like we talked about before. The target should probably be above the nodes. So we want the nodes to be second. And remember that whenever we build our grid, we do go to build grid. Let's go there, go to definition really quickly. And in our build grid, at the bottom where we're adding a child, we also want to change this so that the path node is 1, right? So that is a layer higher than the background worst case scenario. If somehow we're going to show both, right? So path node is going to be 1, so a 1 layer above the background. And then what we want to do is we want to set the other nodes so that they're in the right order as well. So we're going to say that in the start function, right, the cloud nodes would be layer 2, let's say, and the ship and the target, we'll say the target is layer 3, and we'll make the ship on top of everything else. You can also make it so that the ship and the target are underneath the clouds. That's totally up to you. I'm going to make mine above the clouds just for this one. So instead of being layer 3, this will be, my spaceship will be layer 4. And why did we do this? Because if you run it again, then what ends up happening is it kind of displays in the proper layer order now, right? So you can see that the nodes don't kind of wipe out the ships when you're in this mode, right? And also that the background stays in the background, that all the obstacles stay in the right spot. So these are all the obstacles. As you can see, you can move these around, right, to make it interesting, right? As an example, that's what Alex has provided for us. And this is our starting point for the lab. Okay, so now as it says, let's go up and take a look at his notes. And the first part is we have the setup. We make sure that the lab runs as lab 6 did, and it does. Okay, so let's make our first commit, and we're going to use GitHub Desktop for that. So again, GitHub Desktop. We're going to do that as well. We're going to bring that up whenever it feels like coming up. There we go. And we want to do section 400. We're going to say we added project files for lab 7.1. Okay, there we go. And I'm saying 7.1 because, like I said, there's going to be 3 parts to this lab, and I'm just naming them 7.1, 7.2, and 7.3. But you can certainly work in just one lab because all you're going to be submitting is one lab. Push. But I'm doing it so that you can always go back and take a look at the changes and see what we've added, moved, and so on. You can run them as well separately if you really want to, because it's a lot that we're going to be adding in here, and it's good to keep track of all of it. Okay, cool. So that is the first piece. The next piece that we're going to add in is the decision tree filters. And what Alex has asked us to do this time around is he's asked us to add several filters, and this is from an organizational perspective. So again, what you can do is we can go to template and we can add, that's not what we wanted. We can add in some filters, a new filter, and the first one that we're going to add in is going to be called decision. And then under the decision filter, we're going to add in a few more. So another one that we're going to add in is going to be called actions, and then agents, Okay, we're going to add in some more filters. We're going to also add in conditions, and finally core. So we're organizing ourselves this way because I think it's a good idea. He's also said, so we've done that first. Let's go back to what he's telling us to do. So he says, move the spaceship over into agents. Let's do that. So spaceships right now is under game objects. We want to move spaceship to agents. All we're doing is just changing the filter, right? So it's going to show up here now. And this is why we can work in here and not in this whole area here. That's why this organization is the way it is. And next he says, move agent to the core, because that's something that we're going to modify. So from core here, we're going to move this to our core filter down here so we can access the agent object a little easier. And finally, we want to make, he's already added a tree node, action node, and condition node. And we're going to add these things into our core filter. So again, in the core filter, we're going to add in existing items, right? And if you go into our SRC folder, he's saying add in action node. Okay, that's what we want. Action state is already added in our enumeration, right? Condition node, action node, condition node, and he's also got action node, condition node, and tree node. Yeah. So there's our tree node.h, and add them in. So action node, condition node, and tree node. And all we're doing is we're adding existing items because those are already been added in for you as we structure the application. And also, we also have an enumeration called action state, which gives us no action, an attack action, move to line of sight action, move to player action, or a patrol action. So these are the current actions that the agent would probably have. Okay, starting off with no action. And then we also have something called tree node type. Tree node type is either the left tree node or the right tree node. And we use this as a simple way of marking if it's the left node or the right node. Okay. So those are a couple of enumerations we've added in. So also we've moved our ship to agents. And like I said, we've also moved our agent class to core, but we also have a couple of new core classes. Let's start with the tree node class. So tree node class is a brand new struct that's been added in. And what it is it includes a couple things. One is every tree node has a name, right? And we've initialized it here. It also has several pointers. It points to its right child, its left child, and its parent, okay? They all start off by default as null pointer, and it also kind of wants us to know, is it a leaf node or not? If it's a leaf node, then this would be true. Otherwise, by default, it's not a leaf node, it is false. Okay, leaf nodes, remember, are the bottom part of the bottom part of our tree, so the leaves. Let's actually take a look at that. And what I want to do is Alex had a really interesting or simple diagram that we're going to use to build up the tree. We're going to use a diagram that looks like this, right? So at the top of the tree, we're going to have a condition, has line of sight. If it's true on the right side, then check to see if we're close enough to close combat. If we're true, then attack. If it's false, then move to the player, move closer, right? On the left, if as an example, if we don't have line of sight, then are we within radius? If we are within radius, move to line of sight. If we're not within radius, then we want to continue to patrol. And this decision is going to be triggered every frame. Am I within radius? Am I within radius? Am I patrolling? What am I doing? So for this lab, we're going to basically make it so that your player patrols, or the agent patrols constantly. We're going to come back to this, so I'm going to keep this thing up. Interesting diagram again that Alex has drawn. Very simple in terms of a decision tree that we're going to use for today. Awesome. Next, all right, so what we want to do then is after we've added in those filters and changed things up, let's do a commit. All right, so that's the next thing we're going to do. So again, I'm going to say that added filters, commit to main, and push. We've also added some additional features that we've added in, but first, so far, we're about right here, all right? So now what we want to do is add all the action nodes and condition nodes. Okay, now this part here, the tree is going to take a long time, but so do these. These actually take time because there's a lot of copy pasting going to happen here, and we want to do this as quickly as possible. All right, let's do that now. So going back to our nodes, I want to start adding some actions and conditions. We're going to start with actions first. Okay, again, going with what he's telling us to do. So he's telling us action nodes first, followed by condition nodes. We're going to do that. So actions, what kind of actions do we have? Well, if you look at the diagram, we have, these are the actions we're going to do. The action level is the bottom level. These are all the leaves of the tree, right? These are different conditions. So these are conditions, 3 conditions, and 1, 2, 3, 4 different actions. So let's start with the action. We'll start with the patrol action. So how does the patrol action work? Well, we know that we have a tree node, and the tree node that we talked about has it action node inherits from tree node. Okay, so tree node, again, remember it has our left tree, right tree, and our parent. Action node, what it does is it's already been made for you. And what action node does is it inherits from tree node, and action node includes a constructor function that basically sets up or initializes the agent. What is the agent? We're going to keep track of the agent for that particular action. And we're going to say that by default, the actions, all actions are leaves, right? Because they're at the bottom of the tree, right? These are all leaves. So that's what we're saying. So that this is the bottom of the tree. Our default, we have a virtual void, right? Pure virtual function, which makes this an abstract function, an abstract class. And what ends up happening is that we're going to keep track. We have 2 getters and setters, or a getter and setter. We're keeping track of the agent, and we're going to get a pointer to the agent that we're referring to, and we're going to set the agent as the agent that is taking that action. Okay, so that is the action node superclass. We also, when we make a condition, similarly have a condition node superclass. But in this case, the condition node, again, if we look at the conditions, these are not leaves, they have children. Okay. The main condition, which has line of sight, is the root condition. This is going to check left or the right node, right? And if, because this is a condition, it has children, but it's not a leaf node. So you can see that by default, conditions are not leaf nodes, right? As an example. And again, we have a pure virtual function, condition, which is something that you need to override. So condition and action. Right? Those are the pure virtual functions that differentiate. Those are 2 things that differentiate an action node from a condition node, as well as action nodes are leaves by default, condition nodes are not. We also have a getter and setter because we're keeping track of the agent that is going to perform that action, whatever that is. Okay, so those are the 2 superclasses. Let's get into the new classes we're making now. So let's start scaffolding out these things. So I'm going to add in a new item, and the new item, let's make sure that we browse to the right location, okay, in the SRC folder. The new item that we're going to use, the first, is going to be the patrol action. That's the first thing I want to make, patrol action. So the patrol action class, the .h class, we're going to add that in. Here's the patrol action. And the patrol action is, we're going to start off with the regular stuff that we normally do, which is if not defined, right? And it's going to be patrol action, then define patrol action, okay? And end if. We're going to say defined patrol action, right? Pretty cool. And we're going to say that this class, right, patrol action, oh wow, inherits from a public action node, right? And the action node is something that ReSharper is going to ask me to include, which I will. And then we're going to have a patrol action constructor, as well as a patrol action destructor that's in there. And the destructor should be virtual. And what we're going to do is we're also going to have a virtual void action, remember, because the action is going to be overridden, right? So that the action that we're going to take is specific to whatever action we're making. Here we're making a patrol action, and we're going to define what this action is for our patrol action. Of course, this part is all inside the public area, and the private area is going to remain empty for now. Okay, so that is our action node, our patrol action that we're making. So the patrol action is also going to be followed up with new item, CPP. We're going to also have another action, which is going to be the patrol action CPP. That's the other file that we're going to make. Let's add that in. And that it's going to include the patrol action. There it is. And we want that to happen because the patrol action .h is going to, we're going to use generate definitions by declarations, and it's going to create the stubs for us. We're going to set the destructor to default. And what we're going to start off with is that we're going to set the name of the action to the patrol action. So we know what we're doing. Our action actually is going to be very interesting in that this is the only one we're going to define for today, where we're going to say that if my get agent, get action state, if the action state is not equal to patrol, then what we want to do is we want to set the action to patrol. Get agent, set action state to patrol. And we're going to go over the agent in a second and the things that we've changed there. So we're setting and getting something from the agent, and that's one thing we haven't talked about yet. Let's get into that in a second. So here's cout, and sure, let's add IO stream. And what we're going to say is we're going to be performing the whatever action, whatever the name is. Patrol action would be the name, right? Okay, so that is really our patrol action, and that's all that it needs. We're just going to tell it that we're just switching states. We're switching from our whatever state we were in to patrol. Okay, that's what it's going to do. So how do we do this? How do we set the action state of an agent? Well, remember, one thing that Alex has done is ahead of time, he's swapped out, we've added a little bit of agent code. And what he's done is he's added two things to the agent. He's added in a state, which is of type action state. So remember, action state is an enumeration. Action state is either the attack action state, the move to line of sight action state, the move to player action state, or the patrol action state. So agent keeps track of that here, and we have both a getter and a setter for action state. And that's how we were able to do this part right here inside the patrol action. We're able to set the action and get the action. And that's what he's done here. Okay, so that is an example of the patrol action. And what we're going to do is we're going to mimic this patrol action. I'm going to go into the operating system to do this really quickly. So I'm going to go to kind of open this up in File Explorer, right? And in File Explorer, I can go to SRC and I can go to the patrol action, right? And the patrol action has both the CPP and the .h. And what we're going to do is I just need the .h. I want to Control-C, Control-V, right? And what I'm going to do with the Control-C and Control-V is I'm going to make this new action, right? Because remember, we have patrol action, we have move to line of sight action. Here's our move to line of sight action. We're going to do that. We're also going to have a move to player action. Let's do that first. So I'm going to copy paste that one. So Control-C, Control-V. We're going to say that the move to line of sight action.cpp is there. It's going to be the same thing, by the way. We're going to fix those in a second, but one thing at a time. We're just constructing the files that we're going to add in here in a second. And the same thing goes with our move to player action. So Control-C, Control-V. Here's our player action. We're just going to rename these. And I'm doing this in the operating system because it's just faster for what we need to do. Move to player action. You can do that because they're just files, right? They're just, all we need to do is modify this stuff, and they're just text files, right? Move to player action. There we go. So we've added move to player action, move to line of sight action, and we need the attack action. Let's do the same thing with their patrol actions. I'm going to copy these two things, Control C, Control V, and the patrol action now is going to be the attack action. Okay, now we have a lot of work to do, but at least we have the files ready for us to go, which is one part of what we want to do. So you should be doing the same thing now. Let's add them all in. So like before, what we're going to do is we're going to go to the actions. We're going to add, instead of new item, we're going to add existing items, and we're going to add all those in. So we're going to have the attack action. We're going to have to move to line of sight action and move to player action. Okay, those are the ones we added in. Let's add them in. And we can see now we have 4 actions: patrol action, move to player action, move to line of sight action, and attack action. But we need to fix these because they're meaningless right now. Attack action obviously is not a patrol action. Let's change this to attack action. This is also going to be attack action. Okay. Remember, it's easier to destroy than to build, I find a lot of times. So this will be obviously attack action, right? So copy paste. It'll have an action type with an action node, save. And then in the attack action.cpp, this is where the changes go in. You know, sometimes I just think it's best to just wipe this out again, but it's okay. So we'll say this is the attack action. And we're going to say that this is the attack action here, 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 here. Well, that's just the easy way to do that, right? And definitely attack action.h. If you can spell better than me, then you're going to be fine. All right, so that's kind of the stuff we've done. And attack actions is going to be attack action, right? Pretty simple, except in here, we're not going to have this fancy stuff where we do anything. In fact, we're just going to do something that says performing whatever the attack action is. So this is the attack action done. Okay, attack action. Attack action. So what I did was I used the patrol action as a stub, and now I'm just going to do the same thing here. So this is move to player action, right? Move to player action. I'm just going to copy this, and here, and here, and here. Oops, no, not there. This will be move to player action. So move to player action. We do 1, and we just copy paste a bunch of places just to be a little quicker than what we're going to do. So this is move to player action. Everything else is the exact same. Just grab this one. And then we're going to go to move to player action.cpp, change the include. Oh yeah, that was a problem. Let's go back to patrol action.cpp and grab all this. That's okay. And we want to kind of go to move to player action. That's what we want, right? Move to player action. And we're going to go back to move to player action, grab these files, and just modify them, because really there's just a lot of the same stuff. Because at the end of the day, it's just setting up what we're doing together here today, right? And this is move to player action. There we go. We don't need this part or this part, and well, we're done. So move to player action is done. All right, that's pretty cool, and I'll remember that the next time. I think I did a copy paste a couple times like that. That's okay. Move to line of sight action. Okay, so move to line of sight action. Move to line of sight action. This is one of my favorite ones, and we'll put that in there. And this will be move to line of sight action. Move to line of sight action. Okay, and now we know that move to player action might be the closest one. Let's just grab this part. I know that move to line of sight action I messed up and I did that one, but that's okay. And then move to line of sight action is what we want here. Move to line of sight action. Action. Did I make that wrong? Move to line of sight action, move to player action. And yeah, that was pretty wrong, but that's okay. We care only about this part. Move to line of sight action, move to line of sight action. There we go. All right, so move to player, instead of line of sight action, move to player action, or move to line of sight action is what we want to find. That's what we're looking for, move to line of sight action. Let's grab move to line of sight action and replace all of these here, 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 and here. Right, and move to line of sight action is now done. So that's all the move to actions. All the move to, and just to check this, let's just quickly do a scan. Move to line of sight action. Right, we're just doing a scan because we did a lot of copy pasting there. I don't like that, but it is what it is. It's going to save us a lot of time later on, especially next week. So move to line of sight action is good. Move to player action. Let's take a look at that. So move to player. We're just doing a scan. Okay. And finally move to player. That looks good. And finally, the other one is attack action. Okay. And attack action. Again, I'm just doing another cursory check here just to make sure that it all looks good to me. If it doesn't, now would be the time to change things up. This is a great place to put it up on GitHub. Save. So if you're not as fast as me, that's okay. I'm hoping you're faster because all I did was copy paste really at the end of the day. So we're going to say added action, actions, or action nodes. How about that? Action nodes. We're adding all those action node stubs is what we did. We pushed that to origin. So we have those things as well. You can always grab those from GitHub. Next, let's do the next one, which is our conditions. So the conditions that we want to add next, the conditions we want to add, there's only 3 of them, right? Which is, do we have line of sight? Do we have radius? Or are we in close combat? So these 3 conditions are the ones we want to add. So line of sight is the first one, the line of sight condition. So again, we're going to add in a new item here like normal, and we'll say that this is the line of sight condition. So line of sight condition, right? And we'll add this into the same place. It's a .h file, awesome. And we'll do the next one, which is a new item, which is the line of sight condition.cpp. Line of sight condition.cpp. Add that in. Let's do one of them. Let's do our line of sight condition before we do the rest. So this will help us with, kind of copy pasting the rest of the stuff because this is the one that we're going to do first. So we're going to say, if not defined, right, line of sight condition, then define it. And end if hierarchy. Okay, and we need a new class, which is going to be the line of sight condition class, which is going to derive from a public condition node. And of course, #, is going to say you should include a condition node. Yes, we should. Awesome. And here we're going to have a line of sight condition constructor, as well as a destructor, which is going to be virtual. Now, this is something that's new because our line of sight condition, it's a condition. So it needs to take what type of thing that we're looking for. So we're looking for line of sight, which is going to by default equal to false. So we don't have line of sight to start with. We're also going to have some getters and setters. And we're going to have a void setter for line of sight, which is our state, whatever the state is. Okay, is it true or not? We have line of sight. And then we're going to do a virtual Boolean, which we're going to have a condition. This is part of the condition superclass that is required. This is all going to be in the public space. Okay, and that's going to define what we have. In our private area, we're going to have a data member, which is a bool m_has line of sight. Now, this is going to be more difficult to copy paste, but not incredibly so. Okay, so this is the first condition. Do we have line of sight? We can create a constructor. By default, no, we don't. Okay, that's what we're saying. And lets us make sure that the line of sight condition is including our line of sight condition here. And then when we say, as we go back to a line of sight condition, we can use resharper so that we can generate definitions by declarations. We do that, which creates our stubs. We're going to set our defaults. This is going to be defaults, right, as an example. And now we have some work to do on the CPP that's different than what we did before. Well, we know we're going to set our name, m_name. That's going to be the same, which is the line of sight condition. And we also want to set line of sight where we pass in the line of sight to it. Well, if that's the case, this can be const. Okay. If that's the way it's going to be, then set line of sight. Again, we're going to say that m_has line of sight is equal to state. That's just our setter. And then this is kind of our getter, if anyways. We're going to return m_has line of sight. So our condition method is going to really be returning, do we have it? So these are both getters and setters right here. They're just called different things. And of course, this one can be also const. So that is something that is the same for everything that we have. And we spelled line of sight condition wrong. And that's okay because we can refactor rename. We're going to do that. I spelled it wrong in my haste. Line of sight condition. That's important to get right. Because if you don't get that right, that'd be like, wait, what? Tom spelled it wrong. Yes, I did. All right, so this is our first class. Well, guess what? We're going to go back into the operating system now and copy paste, because now we have our line of sight condition. Well, we need to copy this twice more. So copy, paste, paste, right? So then the first one is a radius condition. Let's change that. Radius condition. And we'll do the same thing with here. We'll do a radius condition here. And followed by the last condition, which is going to be our close combat condition. Close combat condition. Close combat condition .h and close combat condition .cpp. Awesome. Let's add them in. Back to here, going back to our conditions. Let's add existing item, right? And we'll add those items back in. So close combat conditions got to be added in, right? We have our line of sight condition we just did, and we need to do our radius condition, which is the other one that we're missing. So that should be all of them. There we go. And let's work on our radius condition next, which is very similar to our line of sight condition. So again, what we want to say is we want to change some of this stuff. So this is radius condition. Let's change this really quickly. So radius condition. So radius condition here, 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 right? Those are changes, right? And this has to be radius condition up here and here and here, radius condition, right? Now, the radius condition, instead of set line of sight, it's going to be set is within radius, which is the thing that it is. And so our data member is within radius, right? That's our data member. And then, of course, we're going to have within radius up here, within radius. Okay, so that's going to be our .h, if that makes sense. Okay. Now we need to make our changes to our .cpp. And just to make sure, we're just going to grab radius condition, and we're going to make those changes. So radius condition here, right? And it's here, 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 and here. And we're also going to change this to radius condition. Okay, which sets up this nicely. Instead of set line of sight, set is within radius. We can grab that and put that here. M_ is within radius is there and there. And this has to be is, or within radius, I think is what we called it. Within radius. Within radius, which is this. Okay, so this will be the radius condition. Okay, so that is set within radius. And I think we covered all the bases. I think this is good. We're going to come check that later on. So radius is done. And let's do the close combat condition. Again, just like before, close combat condition, copy paste. And just like Alex said, lots of copy pasta, which is nice. I like how you said that. Close combat condition. Oh, that's even spelled wrong. That's interesting. We're going to fix that. And that's all right, because we're just going to go and do everything that we have to do. Close combat condition is missing an I, and an I that's here. Wow, that means that we have to check that too. That's okay. I'm going to make sure that everything is spelled properly in a sec. So close combat condition, everything is close combat condition. Close combat condition is different in that this is within combat range. Everything is false starting off. And instead of set line of sight, we're going to set is within combat range, right? And the condition override, this will be is within combat range. Okay, is within combat range. And that is our .h, close combat condition. Let's grab close combat condition now and go and fix up our .cpp. So this is close combat condition. And we'll say paste, 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 paste. Close combat condition set is within combat range, and then within combat range, right? And that's going to be here. And this is M underscore is within combat range, which is here. Whew. Crazy, copy pasting kind of stuff. All right, so combat condition, we had an error. I want to make sure that where that error is. I think this is good, and we're good. Let's check out line of sight condition. Line of sight condition looks good. The condition node looks okay. Just want to make sure that it's okay. Line of sight looks good. And let's also check out range radius condition. Yeah, that's where it's wrong. So radius condition is spelled wrong. Let's just rename it. Refactor, rename. One error, copy the error everywhere else. Condition, radius condition. Radius condition is there, is within radius. Radius condition is spelled correct. Condition node, condition, radius condition. And I think we got all the condition nodes done within a reasonable time frame. All right, let's do that. Let's put that up on GitHub. So we'll say something like added condition nodes and push. All right, at this point, I'd like to ask you, because we're here at the point where we are you with me? Because we've done all of this stuff right now, believe it or not. We're about halfway through in that range. Are you with me? So all I've done is copy pasted. I think you can see how I did it right at the end of the day. I mean, at the end of the day, all we're doing is making some very simple structures so that way we can fit it into our decision tree. That's what we're doing. So we're going to build this decision tree now. We got to think about what we need, right? We need to have a left and a right node. That's what we're going to have. So the decision tree is going to be a list of tree nodes. That's what they're going to be, right? A list of tree nodes with a left, a right, and a parent. Each one is going to have a left, a right, and a parent potentially. Okay, so let's do that next. So let's go back to our C++, and that's what we're going to do next, because that's what Alex told us to do. we're following Alex's thing. We're going to add decision tree. We're going to put that inside of the, the core filter. Okay, and this is what's going to take us a bit more time. And now I'm going to slow down a bit because we need to kind of talk about what these things do. All right, so let's do that. So we'll say add new item. And here we're going to add in a decision tree. Decision tree. Sure, we can add the CPP first. It doesn't matter, right? And we can add also in the add new item, which is the .h. Typically, I like to add the .h first, but it's okay. Decision tree .h. Again, make sure you spell everything properly, guys. Otherwise, later on, you'll be like, oh man, I got to refactor. So here's my decision tree.h. The way it's going to look, of course, is this is going to be bigger. So it's going to be, we're going to start off with decision. So if not defined, decision tree, then define it. I just like to start with those. Okay, and then we'll make a class. The class decision tree is not going to inherit from any other class. It's going to be composed of tree nodes. Okay, that's where we're going to start. With every class, we want to have a public area and a private area. And we're going to have a constructor function, one or more. We're going to have two in this case. And we're also going to have a destructor function. We're going to have some getters and setters, which are like accessors and mutators. Okay. We're also going to have some public utility functions that we're going to use. Utility. There we go. And these public utility functions are going to be adding functionality, to our decision tree, right? In the private area, let's start with those. What do I want to carry in? Well, I want definitely an agent. I want to kind of keep track of the agent that I'm using, and for that we need a agent.h. All right, we need to start with that agent.h because we're going to have an agent data member. Let's call them m_agent for now. And we're also going to have a couple of additional things. I'm going to keep track of my line of sight condition and my radius condition and my close combat condition. These are all condition nodes. So again, I need my line of sight condition. Line of sight node. And it's asking us for the line of sight condition. Thank you very much for that. We also need a radius condition pointer. And why isn't this asking us for anything? It does. Finally did do that, which is M1 line of sight radius node. And we also need a close combat condition, which is the close combat node. And it needs to add those in. We're just going to add in the close combat node. So those are all things that are added in the right order. And this is all part of the stuff we're keeping track of. We're also going to have so these are all data members. We're also going to have an array, right, of tree nodes, right? That's what we need to have as well. So we're going to keep track of, kind of a list of tree nodes. So we're going to have a standard vector of type tree node pointers, which we're going to call tree node list. Okay, and that tree node list, what we're going to do with it is, and let's just make sure that we have tree nodes because we've included these things ahead of time. And each one of these things inherits from tree node, and that's why we don't need to actually look at it. But just to be nervous, I'm a nervous type, there's nothing wrong with including tree node as well. Okay, I'm not going to be nervous about it, but that's how it is. The other thing that we're also going to probably need is the tree node type, right? Which is we want to keep track of the tree node type that we're looping through. Okay. And then we're going to have a private methods, private methods, yeah. And the one that we're going to have is called m_up_build tree, which is going to be our main method. It's going to take a bit of time to construct. All right. So we have a list. So tree node list, right? We're going to have our private instance members, private data members to keep track of stuff. And those private data members are just going to be pointers to things that we're going to be kind of keeping track of in our decision tree. Our constructor function is going to obviously look like decision tree. That's our default. We're also going to have another one that is going to take an agent pointer, okay? And we're also going to have a destructor that is we're going to use, okay? For getters and setters, we have a few, right? So we're going to have get agent, and sure, we'll make it const. We're also going to have line of sight condition pointer, get line of sight node, const. We're also going to have a radius condition, get radius node, const, as well as a close combat condition pointer, get close combat node, const. And finally, we're going to be able to, those are our getters. We're also going to have our setters, which is our void set agents. We're going to pass in an agent pointer, and we can set the agent after the fact, after we constructed the tree. This decision tree agent is actually a utility constructor to help us set the agent at the same time we're constructing the tree, which is kind of cool. For public convenience functions or utility, or we'll say convenient utility / convenience functions, right? What we're going to have is one that allows us to add nodes to the tree. So we'll say tree node is also going to return a tree node pointer to the one that we're adding. So we'll say add node. What we're going to add is a tree node pointer that is, tell me what the parent that you're adding on to is. So what is the parent? And then we're going to say that you're going to tell me, you're going to specify what child node you're going to add, whether it's going to be an action node or condition node, followed by the tree node type, which is going to be the type that you're adding in. So what does this do? So in other words, I'm adding, let's suppose I'm over here, I've already got my root node because we're going to add the root node manually. And I'm going to say, okay, I'm going to add in a close combat condition node. Okay, now where am I going to add it in? I'm going to add it into the right child of, what's the parent? My has line of sight, or the line of sight condition. That is the parent of this one, right? So I'm adding it to the right side. Okay, so that's what I'm doing here when I'm adding it in. Okay, and then we're going to display, we're going to update, and we're going to clean. Okay, those are the three functions. Those are kind of like life cycle functions that we're going to use. We're also going to, this is a very important one, make a decision. Because that's what we're going to make with this thing. And we're going to use in order traversal to make that decision. Okay, so that is the root, or the main thing of m_agent spell wrong. Did I? I did. Thank you. Thank you for that, Ethan. You're watching. That's what it means. All right, so that's pretty cool. So we've got all of this insanity, and it's the first part of what we need to do. Because without this part, right, without this part right here, we can't really do anything for the CPP. This is our structure, and if we think about what we've added in here, again, just to go through it again, 2 constructors. One that gives us a convenience to add an agent, this agent here, while we're constructing everything. Getters and setters that allow us to, now again, we're doing a bit of hard coding here, okay? So do we really need the line of sight condition pointer and the radius condition and everything else? Well, yes, the way we're constructing the tree in this particular example, yes. Could we do it differently? Absolutely. Do we need a reference to the agent? Yes. These things, maybe not, right? Not specifically, but we're doing it because it makes our life a little easier right now as we're constructing the first version of your tree. Okay, cool. Let's do the next part, which is the decision tree.cpp. In the decision tree.cpp, to make that fast, we're going to say include decision tree.h. That we need. And then we're going to go back to the .h file, and I'm going to go to the class, and I'm going to kind of generate definitions by declarations. You can see there's a lot to type in here. We're going to do the easy ones first, the low-hanging fruit, so to speak. We'll get those done first. So the low-hanging fruit are the constructor, the destructor, and some getters and setters. Those are easy to do, right? So if we think about what the constructor looks like, right, we're going to say something like, okay, well, m_agent is something that we don't have, but we can do build tree. So m_build tree. That's what's going to happen in the decision, the constructor. And then here we're going to say agents, right, is equal to agents. We're going to do that. And we're also going to build tree, right? Now, again, something you could do is you can use this constructor to call the other one and just call agents. So you're only having one constructor being called ever. And that's really your design decision if you want to make that. This is going to be defaults. So this is going to be something that's pretty simple. Get agent is going to return agent. These are easy things to knock off, right? We're also going to return m_line of sight condition. So the line of sight node. And we're going to return m_radius node. We're going to return close combat node. These are all easy to do. So this is quick. All right, so those are returns. Set agent, again, is kind of the same thing. m_agent is equal to agents. When we do that kind of stuff, it's going to probably want us to make this const, but for now, no, we're good to go. These are all const functions, right? Add node, we're going to come back to this. Display, update, and clean. Make decision and build tree. All these functions here, well, that is a little bit heavier than what we've done so far. This is what takes most of our time. And let's get into this slowly as we go. Okay. So far, so good. We could also, by the way, up on top here, we called build tree, we called agent, we could have called set agent, but we don't need to do that. Okay, so far, so good. Let's do the add node next. So how does add node work? Well, we're going to do a switch case on type, and that can be const. Because once we're switching type, we know that that can be something we're going to add in. We're going to say, well, case left tree node, then do something. Case right tree node, then do something else. So if it's the left tree node, what do we want to say? What is the parent that we want to say? Well, we can say that parent, whatever the parent you're adding to, the m_p left child is going to be equal to the child node. So you're adding the child node to the left child of the parent. That's what you're doing here. And then, hey, parent, if it's the right node, if we specified in the tree type node it's the right side, well, then we want the right node to be this child node that we're adding in. Okay, that's what that does. And then followed by, hey, child node, let's make sure that your parent of the child node is equal to parent. Okay, and finally, let's return out that child node. Let's go over this one more time, right? So we add a node to the tree. How does this work? We have to specify its parent. We have to specify its parent. That means we cannot add a node to the root. The root has to already be there. Okay, that's something to note. Okay, we indicate what this child is. It's a tree node type, which means it could be a action node or a condition node. One of those two types of nodes we're going to add in. we're also going to tell you which tree, which side I'm going to add it in, the left side or the right side. Okay. Tree node type may not be the best name. It could be tree node subtree type, subtree. Maybe we'll change that later on. But the idea is the same. Then what we're doing is we're setting the child node's parent to the parent node that you specify. We're making that connection. And we're doing it in one little function here. What does display look like? Display is not so bad. We're going to say for each node in the tree node list, for each node, in the tree node list, what do you want us to do? Well, we're going to do a cout. Let's add IO stream. And we're going to say that the node name is something that I want to print out. Okay, that's where we're going to print out the node name, whatever that node name is. And then the update function we don't have yet. This is TBD, right? We're going to see what that is. Do is really do something in the play scene, right? Where the main scene that it's operating in. Clean is actually going to clean things up. That's kind of deletion. So we're going to do a for each loop, where we're going to loop through each member of the tree node list. So each node in the tree node list, we're going to loop through, and we're going to delete the node. We're also going to say that the node is set to null pointer. That's going to take care of any dangling pointers. We're also going to say that the tree node list, we're going to clear that list. And we're also going to set the tree node list shrink to fit, which is going to reduce the size of the list. And some optional reductions as well is the line of sight node, we're going to set to null pointer because we're keeping track of that. And the radius node, same, as well as the close combat node. So all that stuff is going to be cleaned up. Again, is it really necessary? No, but if we ever call clean, we want that to happen. Next, how do we make a decision? Well, this is where it's interesting. We're going to start off with the current node. And the current node is equal to m underscore tree node list 0. So that's the top of the list, or the root node. And what we want is while the current node is not a leaf, as long as the current node is not a leaf, right? So we're looking through the entire list, right? What we're going to say is that current node, and what we want to say is, let's suppose that current node has a condition. Well, we can't really check for a current node to have a condition because the current node could be any kind of node. It could be, as an example, it could be a condition node, or it could be an action node. We don't know which type it is, but we know that it's not a leaf node. And if it's not a leaf node, it must be a condition node. So therefore, we should cast this thing, this current node. Let's cast it. We'll do a dynamic cast. We'll cast this node as a condition node pointer. Okay. So this is the current node. And then if we did that, now we can say, well, okay, the current node, if the condition is true, then what do we want to do? Well, we want for you to return, to set the current node to the current node right side, right? Otherwise, if it's not, then I want to set the current node to the left side. This is using the ternary operator. I'm just breaking it down so you can see it all on one screen. Okay, so basically what I'm saying is the current node is either the left node or the right node. It's going to go to the left node or the right node because we're going to traverse. If it's not a leaf, decide whether I want to go left or right. Change my node to left or right. That's what this is saying, right? If my current node is positive, if the condition is true, then obviously I want to go to the right side. If the condition is false, then go to the left side. That's where the node is going to look like. So in other words, I'm saying start at the top. Is my condition true? Then go to the right side. My current node is now the right side node, right? That's what this is. Okay, and then what I want to say is I want to, now we're at the next node, which is going to be an action node. All right, so we're going to say static cast this time. Static cast the action node, an action node type. Let's select that action node. And we're going to say that the current node, static cast the current node as an action node and run that action, whatever that action is happens to be. Okay. Okay. Let's think about this, how this works. So it's a while loop, which means that I'm looking at the current node every time. All right. So let's start off the top. So I'm at the top of the current node has line of sight. Is it true? If it's true, then set the current node to within close, right? Close combat range. Okay. So while the current node is not a leaf node, okay, keep going. So now, is the current node a leaf node? No. Cool. Is it true? Am I within close combat range? Let's say yes. Cool. Well, guess what? Now we're going to go to the next node, right? And the current node is the right. The right of the current node is this one. Is it a leaf node? Yes, it is. That means this condition exits. And when this condition exits, it now goes to the action node. What action node am I pointing to? I'm pointing to close combat attack. That's what I'm pointing to. Do that action. That's how it works. Okay, so this while loop, what it does is kind of interesting. It sets the next member, right, by deciding whether I'm going to go right or whether I'm going to go left. Okay, I'm going to go right if the condition is true. I'm going to go left if the condition is false. Let's try this one more time. So again, let's suppose I don't have line of sight, right? My current node is this one. This is my current node. If I don't have line of sight, it chooses the left path. Okay, cool. Now my current node is within, I'm within radius. Am I within radius? Yes. If I'm within radius, then it goes to the right side, right? I'm within radius. I move to line of sight, right? So move to line of sight is the action that I take because it's now a leaf node. And so I exit this while loop. I don't do this while loop anymore. And I take the next action, which is the current node, which is the right node, which is the move to line of sight action. Okay. So the while loop actually traverses the tree because it keeps changing the value of the current node. It points to whatever the other node is. It's a very simple way of traversing the tree. So make decision actually traverses the tree in order. So it's an in order traversal. Okay. So a very interesting way of doing stuff. But now we don't really have a tree. And the next part is to build a tree. And what are they telling me to use dynamic cast? Yeah, saying to use dynamic cast. I'll do dynamic cast. It doesn't matter. So now it's telling me to build the tree. Now, how do I build the tree? And this is what takes a bit of time, guys. So we'll do it together. But let's talk about how to set the node. So first I want to create the root and add, let's say, the root node. Because without the root node, we can't do any other additions. So I want to say m underscore line of sight node. That's a new line of sight node, right? Line of sight condition. And we get a pointer for that. We're going to say that the tree node list dot pushback, we're going to immediately push back directly to the tree node list, this initial node. So that is going to be the root node, the line of sight node. Remember? Here's the line of sight node that we pushed onto the tree. Okay. Next, let's start thinking about the left tree, m underscore radius node. We're going to say that that is equal to a new radius condition, okay? And we're going to say we're going to use the add node convenience function where we're going to say that the parent of the radius node, right, is the line of sight node, okay? And we're going to say that the one I'm adding is the radius node. So the radius node is the new thing I'm adding in, and it is on the left side of the tree. After we've done that, we're going to say that m underscore tree node list, let's push back the m underscore radius node. Now, theoretically, we're pushing back every single time, right? Whatever the tree is that we're adding in. So theoretically, we can do this step inside of add node. So if we look at add node, we could push back that automatically. We could. All right, that's something we could also add later on in our thing. So what we've done here, we said, okay, we've added the left tree node. Well, the left tree node is the radius node. This is this one, right? So it has line of sight, and then the left one is radius. Now we're going to do the right one, right? And let's just copy paste. Instead of a radius node that we're creating, what do we need to create? A close combat node. So let's put that into place. So m underscore close combat node, right? That is equal to a new close combat condition, right? And that close combat node is also going to have the line of sight node as its parent, except this time it's going to be on the right tree node, right? And we're going to push back the close combat node. So now we've made our initial tree, okay? Just to give you a sense of it, we've done this one, and this one. These are all conditions on the tree so far, okay? And now we're going to add in our actions. So these are the conditions. Oh God, I can't spell anything today, man. Woo! Then again, I never can. And then over here, these are our actions, right? So what are our actions? They look very similar to conditions, right? When we start off with the left side. So we're going to start off with the patrol action. The patrol action, right, because this is the leftmost action. The patrol action, when we're building up our tree, is going to have a parent of the radius condition. So the radius condition is going to have a patrol action that is beneath it. So we're going to say that, okay, tree node pointer, patrol node is going to be, we're going to add node, right, m underscore radius node as the parent. And we're going to say, we're going to make a new patrol action happen. We're going to add the patrol action.h to the list, right? So another way you can do it, we don't have to keep track of this one. And we're going to have this, we're going to put this on the left tree node. So this is why when we return the child, so the child is going to be returned of the thing that we're adding in. The new patrol action, instead of us doing it, so we're storing it inside of our tree, here we're making it so that it only stores it here, okay? And it's temporary. Then we're going to do a static cast or a dynamic cast. It doesn't really matter. It's probably going to ask me to do a dynamic cast, where we have an action node pointer for the patrol node. And the reason why we have to do this is because we have to set agent to the agent that we're pointing to. So the agent, remember, we have to keep track of our agent because the agent is going to perform the action, whatever that agent happens to be. And then we're going to say the tree node list, we're going to push back the patrol node. Again, I think we can probably bury this pushback thing inside of our add node. I think that's something we can improve because this is the one thing we're going to do. So there's the tree node pointer for a patrol node. Okay, static cast, it doesn't like that. Let's replace static cast with dynamic cast. I think it's liking that more, right? And this is our first action. This is our patrol action. That's what this is. Okay, let's add the next one. So tree node pointer. We're going to call this move to line of sight node. That's going to equal to an add node. We're going to use the radius node again as the parent. Okay, so remember here we did patrol node. This is the radius node. Move to line of sight node is the one we're doing now. Okay, so move to line of sight node is going to be the radius node. We're going to say new move to line of sight node. Move to line of sight action. It's going to ask me to add it in because it doesn't know what move to line of sight action is. Move to line of sight action. Did I do this right? Move to, oh yeah, move to lowercase o. Move to line of sight action. Now it knows what it is. There it is. And then it's going to go, well, where am I going to go? It's going to be on the right tree. Okay. And then what I'm going to say is, so here's something else. Do I need to set the agent again every single time? Well, yeah, I probably do for each of these nodes. And so we haven't, it's going to be something that I do. Like I'm doing the patrol node right now because the patrol node is something that I'm going to use, but we need to do this static cast over and over again. So this or dynamic cast. So instead of it being the patrol node, we're going to do it for the move to line of sight node. Again, this is a little bit different than what Alex did, but it's just going to be more next day. So you can see I've got both of those, and I'm pushing back the move to line of sight node. Okay, cool. So this is the leftmost tree done. This part, left subtree, all right? And actually the left subtree is all of this, right? So what about the right subtree now? So within close, that means close combat range, that's this piece. This is the root of the right subtree, right? So again, let's copy these two things since we have them, and their actions. And what we want to do is on the left side of the close combat range, it's move to player action. So this is the move to player action, move to player node, right? Move to player node, we're just going to take this and copy paste it like so. And add node, move to player node, the close combat node is here, m_close combat node is this one. And this will be the move to player action, move to player action. And now it's going to, of course, ask me to add that in. So we need to know what that is, move to player action. This will be the left node, and it looks pretty good. Move to player action. Cool. This close combat node, just so I get this right, is this one, right? This on the right side, this will be the attack action. So this will be the attack node. Attack node, we're going to take this and move it over here and here, right? So here's the attack node, and it's going to be the attack action, a new attack action, right? Where we add that in, and this will be on the right side. So now we've constructed our tree. Do you understand the construction? Okay, so Tarif says, what happens if you only have a right side node, but it wants to go left? Well, remember we talked about this. Well, the way we're creating stuff is we're making it so it's a balanced tree, okay? What if you did that? You'd have to make a condition so that there is no left tree. If there's no left tree, then you're going to say, if there's no left tree, you're going to move to the next one. You're going to continue. Because you can't do it. You can't go to the left tree. You're going to have to go back. You're going to have to traverse back to whatever. You're going to skip that one, right? You can't do the left tree if there's no left tree. You can't do the right tree, right? And also, if you think about that, right, where that is possible, that is definitely possible, but we haven't set up that way for you. We've made it very simple conditions here, okay? But it's a really good question because what do you do, right? And that means, I'm just going to go back up to the make decision. This is what you're talking about. So, okay, so we're saying, okay, if it's not a leaf, and if it's true, go right. If it's not, go left. Well, here, underneath here, we're going to have something where if the current node doesn't exist, then what do, right? There is no current node. You can't go right, and it's false. Well, you're going to have an action there. That's going to have to be a leaf node, right? So we would have to have set up a leaf node or something, because the way the tree would look is kind of weird, right? If we set it up. So imagine if you had that kind of condition. So imagine if you had this structure, and you didn't have a right node at all. What would the right node be? Think about it. Has line of sight, and then are you close? No. Or yes, I'm close. Well, I need to do something. What am I doing if I'm close? Right? I mean, sure, you could make this look different. It's possible. But you want to make a decision tree as balanced as possible, as much as possible. It's possible that you won't have it, or you might have two other conditions, as an example, but that's okay. Like if you have, it's not balanced. Like for example, it stops here, this is an action here, but here this is a condition. That is okay. This can keep going on a condition track, right? It can keep going down the condition if it's to the right. So if I have more conditions, let's say as an example, I had another subtree, a right subtree or a left subtree to one of these nodes. These nodes, then one of these nodes would not be a condition, an action, but rather a condition. That makes sense. But there's got to be, at the bottom, there's got to be all actions. That's how it works. All right, but it's a good question. All right, so that is your build tree. Let's put this up on GitHub. I think that covers everything that we need so far. This is the big work that we have to do, that we haven't had a chance, that we wouldn't, that this is something that takes up most of our time. All right, so let's do that. So we'll say something like added decision tree. Okay. Commit to main and push. So that was the big one. The decision tree that we created is very basic stuff that we can take away. Takeaways for this one, right? To me, build tree, we have a lot of hard-coded stuff that's inside of our decision tree.h, right? Do we really need to do build tree as an example within our class, or decision tree class? No, we could probably even do this on the placing side if we really want to, right? At the end of the day, do we really want to keep track of all of these nodes? As an example, this node, and this node, we really don't need to keep track of the nodes. We can do it this way if we really need to, all right? So we never have to keep track of anything, which means in our decision tree.h, we probably don't need this stuff at all, right? These parts, probably don't need to. However, we're going to see that it's necessary, right? We're going to see why these are necessary in the future, okay? All right, so that is our tree structure. That's awesome. Let's move on to the next piece that we're going to put together. So the next piece, if we follow through, we've done the longest piece. This part is the longest part of the lab so far. Now the placing.h and placing.cpp, let's add a new decision tree to them. So let's start with the placing.h. It's been actually done for us, right? So if I go to the placing.h, let's go there, placing.h. And what you're going to see, right, is that the placing.h has already been completed, because if you look down, for lab 7, we have a ship position and an angle. This is something that Alex added in there for us. He added this part in there. That's the one thing that he's done, right? And what we want to do is add a decision tree. So this part is the only part we need to do. So we're going to say decision tree pointer. We're going to call this m_decision tree. Okay. And it's going to say multiple choices, but we're going to include this one. So that's the one thing we need to do on the .h. Okay. Because this part's all been done for us. This part was the part that Alex had already constructed for us, new for lab 7. That's kind of neat. And we're going to see what it does. All right. Decision tree. Next, we want to instantiate this decision tree inside of our placing.cpp, right? And we need to make some additional changes. We're going to start from the very top, and we're going to skim down. So as we get to this part down here, in our update function, right, as an example, we know that decision tree can make decisions. We're going to call that in here. We're going to say m_decision tree, make a decision. Okay, we're going to do that every frame, every single time. If it's in a different state, we're going to check to see if it needs to be checked, and then it's going to make a decision every frame. That's what it's going to do. Okay, so if I have to change my decision, that's what this is going to do in the update function. Okay, scrolling down. So in the start method, or in the placing, we've got the background, we've got the target, we've set up everything. Here's the obstacle creation. Again, we put ours in a class, in a little separate method last time, but it's not really required. Just to show you what this is, we've added our spaceship and our we've also set this up. We set up our grid, and then in the bottom where it says create decision tree, this is where we have to do that. So again, we're going to say m underscore decision tree is equal to a new decision tree. We're going to pass in m underscore p spaceship as the agent. We're using our overloaded method, overloaded constructor to do that, because there's two constructors, one that is the empty constructor and the other one that is the overloader constructor. Decision tree, we're also going to display the decision tree to see if it worked. Typically this is optional. We don't really need you to do this. And also m underscore decision tree, we're going to make a decision for the first time. So we're gonna make a decision first, and then every frame we're gonna keep checking. So that is the creation of the decision tree itself. All right, and we're playing our music, we're setting our GUI function, and in the GUI function, I just wanted to show you what he set up. He set up Lab 7 debug properties, which is pretty cool. And more or less, all of this is the same as Lab 6 for the most part. He's moved some of this stuff off, so it updates as opposed to being here inside of this this area, right? And for the most part, nothing here has really changed. Okay, everything else is pretty much the exact same. Okay, awesome. So that is this piece. Okay, so this piece here, which is our placing, and we just added the treat code to the update and start method. That's the only part we needed. Okay, last part. Let's the spaceship.h. Let's put this up on GitHub first. So again, we're going to go to GitHub, and we're going to do the same thing. We're going to say added decision tree, or we'll say instantiated decision tree in placing, which is what we did. Push. And the last part is updating our spaceship so it tracks. All right, and this is going to do the patrol part. Okay, so let's do that next. So back in here, we're going to go to our spaceship. The spaceship is inside of decision now. It's an agent. Let's go to the spaceship.h, and let's take a look at what the differences are between the spaceship.h that we had and the spaceship.h that we're going to modify. So this is inside of our agent, spaceship.h. So again, spaceship.h has getters and setters, and it has set max speed and so on, some public functions. And all of these look pretty good, but as we go down here, you can see that in the private area here, where it says new for Lab 7, it added in, Alex has added in a vector of vec2s, a vector2 array is what this is. So think about this, a vector2 array, so an array of path points. That's what it is, right? An array of path points. We also have an integer called waypoint that we're going to use to go from one path point to the next. That's what this is. That's added new for Lab 7. So he's already done that for us. And what about spaceship.cpp? Okay, these were all the changes come into play. So spaceship.cpp, let's go to from the top. So in the constructor function, we have bounds, accelerating, colliding, and all this kind of stuff. But then there's an area here that says fill in action state in patrol code. So thank you, Alex, for that. And so what this is we're going to set our action state. Set our action state, if I can actually type to, we're going to start off as no action. There's no action. And then we're going to set the patrol points, or a patrol path, if you will. What is the patrol path? We're going to say patrol, push back, and let's start off with the first GLM vec2. Alex suggests something like 760 by 40. Okay, if we think about where that is on the screen, okay, let's just draw that out for a second. So if here's the screen, 760 on the x-axis is way over here, and 40 on the y-axis is up here. So this is the top right, up here. Okay, so we're going to go from top right to bottom left to top left, and the ship is going to continue to cycle to these points every single time. It's going to seek to those points. Okay, that's what's happening there. So that means that this one is the top right waypoint. Okay. And then we're just going to copy this and we're going to just add a few more. And it's going to go from the top right to the bottom right. So notice that this is the kind of the bottom side of the screen. So bottom right, right? And then it's going to go from the bottom right to the bottom left. And in the bottom left, it's something like 560, same level, and 40. And then from the bottom left, it's going to go to the top left. Okay, so that's, I'm just going to take out the word waypoint just to make it nice and clean so you can see what it's doing. So why 40 and why 760? Well, what Alex has done is he's tracking individual path node targets here, the way he's doing it, okay? All right. It also recommends using in placeback instead of pushback for a vector2 object. That's okay. We're going to start off with our waypoint set to 0. And our waypoint is going to start off at the first waypoint inside of our patrol path. Okay. Next, what we want to do is we want to set the target position. We've never done this before, to our m_patrol and to the first waypoint. So the first waypoint is going to be waypoint 0, which is going to be the top right corner of the screen. So that's going to be the first target position. Top right. All right, so that's the way we're going to do our patrol path. It's going to set up a patrol path just like this. Next, do we do any changes in draw? No. How about the update function? Absolutely. And it says, determine which action to perform. Well, we're going to make a switch case where we have get action state. And we're going to say that case patrol, if we're doing the patrol action, then what will we do? Well, if we're patrolling, then we're just simply moving. We don't have an attack action state yet. Okay, that's the move action. That's what we're going to patrol. And this is going to be an update, which means this is going to be called every frame because the spaceship is a display object at the end of the day, right? Then move is going to be called every frame. Get max speed, get acceleration, get all these getters and setters. We're going to come back to seek now, and this is where seek is going to be updated. Okay, now this is where it's going to be a little funky. Let's talk about this a little bit. If util distance, we're going to check the distance between my patrol point. So we're going to start off at 0, right? If the distance between there and get transform dot position, right? That's where the ship is right now. If it's less than 10 units, if it's less than 10, then that means we're pretty close. If, and we're going to increment the waypoint first, m_waypoint. If the waypoint, the new waypoint, which is waypoint now being waypoint 1. So we're at waypoint 0. If it's waypoint 1, if that is equal to the m_patrol path, that's what that is, size, right? Then what do I want to do? I want to reset my waypoint to 0. So what this little piece, this little if statement does is it check to see if you are at the last point in the path, and if so, reset. So it resets it to the first point in the path. That's what this part does. Okay. And again, you might want to think about patrol, what this is. Let's just change this because I'm just stickler for this kind of stuff. Let's just rename this to patrol path because that's what this is, a patrol path, right? And so now if we can simply say if my patrol path size, if my waypoint is equal to the patrol path size, then set it up, right? That means the waypoint is pointing to the last point in the path. Okay. Next, we have our set desired velocity. But before we do that, inside of the, this is the seek function, right? And we've done reset. After if we don't reset, let's say we're not at the last point, then what do we do? Well, we're going to say that we're going to set the target position to the new patrol point, whatever that is. When you patrol path waypoint. Remember, waypoint has been incremented at this point. We're incrementing waypoint. That's what we're saying. So increment before, this is a prefix, right? And then once we've incremented waypoint, this will be waypoint 1. So set the target to the new waypoint is what it's saying. Okay. Desired velocity stays the same, right? All this stuff stays the same. Look where you're going stays the same. And then seek stays the same. So basically the rest is, as we say, is done. We're already ready to go. Let's save that. And now finally, let's save all. And maybe we're going to have some kind of error. We haven't tried anything yet, but so far so good. It hasn't given us any errors as we're typing. We typed in very simple things, right? So let's see if it gives us errors. We're going to track stuff. We couldn't test it really until now anyway, because we haven't had the ability for our ship to move or to do any of that stuff. Let's try it out. So run it. It's going to rebuild the application. Okay. It's going to rebuild the application. And when it does so, we want to look for a list, the decision tree itself. Okay, so it's going to patrol, which is pretty cool. Take a look over here, though. We have line of sight condition. That's the first condition. Then radius condition. Then radius condition, right? And then it's close combat condition. That's this one, right? And then it's going to load the patrol action, this one, followed by the move to line of sight action, followed by the move to player action, right? Followed by the attack action. So it's printing out the tree in the order, which is pretty cool. And notice the last thing it says is performing the patrol action, because that is what the player is using. Why? Do I have line of sight? Well, we didn't check for that. We don't have we're not changing this action right now. We're saying we don't have line of sight. Okay. We can't detect it for close, and we can't detect if we have radius. So that means that it's going to say no line of sight. We don't know if it's radius, which means it's going to be here. So every single time, it's always going to do patrol. And then let's see what is happening now. So we have our ship. It's running around, right? The Reliant, right? And the Reliant is moving around the Enterprise, okay? And we can have our little grid. You can see that the grid is updating. We can even check to see if the ship is, we can move it in a different direction. For example, if I want to, I can shift it somewhere else, like over here, and it'll just come back. Right, there it is, it's coming back. And we can turn on the grid so you can see the grid. Right? So I want it to move this way, I can do that, but it's going to move back to its path, no problem. I can check the node to the ship. These are the nodes, the line of sight that the ship has. Almost think about it as if you think about this, it's almost like it's casting a light. That's what this thing does. Wherever the ship can see, it's casting a light. These are all the nodes that can see the ship. Right? So in many ways, it's casting a light in all directions, and it's being blocked by these obstacles. That's what's happening here. It's kind of neat. So notice that there's some spots, as an example, where it has line of sight. So line of sight to the ship. But what about if I want line of sight to both the ship and the target? So I want to do that, which is kind of neat. And what it does is it provides me this path. It kind of shows me where I can shoot the target, if you think about it, every single time. Because both the ship and the target have to have, that's got to be true for both things, right? So as I'm moving now, you can see that I have no line of sight. All right, these nodes are coming up on board where they have not line of sight to both. As soon as I get to this node, I can start firing at the target. right? Again, it's casting a light into areas where I can fire, right? That's what it's doing. See that? So it's out of arc right now. I'm only these nodes. If I move back here where they have line of sight to hit the ship and the target, I can draw a line to these two things this way. So here there's no line of sight anywhere. I can't possibly hit, as an example. Okay, very interesting. And that, my friends, is your lab. Questions around this? Let's put this up on GitHub for the final push. So this is, we've not just that, but we modified the ship. We modified the spaceship as an example so that it can patrol. So added patrol action, right, to spaceship, because that's all I can respond to right now. All right, and push. Makes sense? So again, what we did was we built this tree. We built it manually. We created a decision tree structure, right? And in our code, if you look at what we did, we defined actions as well as conditions. That's what we did for our decision tree. We converted our agent to something that can use the decision tree and its actions, right? And we also defined some superclass objects that we want to use. Our tree node class, which is something that is a struct that is being used by our decision tree. That's what's happening. The decision tree keeps track of a list of tree nodes, and tree nodes can be of type action node or condition node. Those are the two different types it can have. Okay, and that's what we kind of did for you this week. Again, just to go back to our PowerPoint briefly, then a reminder that Assignment 3 has been updated and is now due Sunday at midnight. That's next Sunday, not this Sunday. That's week 12, not week 11. This is week 11. That's one thing. And next week when we get back together, we're going to build our move to player action. We're going to build our move to line of sight action. We're going to do more of these things that we haven't done so far. We're also going to revisit seek and arrival, because we're going to need to have these in place in order for us to do a move to action. Okay, move to player, move to line of sight, move to range. Okay, does that make sense? And next week's lecture is interesting. We're going to start talking about something called goal-oriented behavior, which is where your agent actually has goals, things that the agent wants to do, that's been programmed to do. Not just behavior that it's going to take on decisions, but things that it wants to achieve, goals that it wants to achieve. Okay, so that is what we're doing right now. Any questions before we go for the day? Remember to fill out to start thinking about your lab report and what it's going to look like, right? The lab report obviously is not up right now, but it will be in a couple weeks. So the great thing to do is build up this part right now. Don't wait until next week so you understand what's happening. It's important, guys, that you do each part of the lab in order for you to understand the complete lab. Otherwise, when we get to your final version, even if you complete it and you hand it and you submit it, you won't understand it. Okay, any questions before we go for the day? Okay, guys, thanks to Alex again for his wonderful work on the lab. I think that's awesome that he did that for us, and he made me smile, that's for sure, because I'm a big Star Trek fan. And I'm hoping it made you smile with some of the music and the theme that he put together for this week's lab. Okay, guys, thank you so much, and we'll see you guys next week. I'll stop recording now. All right, take care, guys. Thank you.